a small introduction about neuromorphic computing, because we thought about leveraging our experience and knowledge in space systems and the way that the data should be processed on a satellite, that led us to think that a neuromorphic computer would fit perfectly on a drone. And why is that? Is because it is a totally different way of compute and process and leverage artificial intelligence on board, because it goes away from the famous von Neumann bottleneck, meaning that the flow is usually the CPU takes the data from the memory, it proceeds to the inference, and then again move the data and transmit the data to the memory. So those back and forth actually is the reason that the neural networks work more in data transmitting, not data processing. And that's how neuromorphic computing come to overcome this issue. And moreover, it has some advantages, such as being quick, to not consume a lot of power, and to be a decent performance. Not a significant performance drop that in most of the times is observed in quantization devices that use quantization, like hardware accelerators. And what neuromorphic computing is making different is that it actually mimics the human brain with the neurons and the synapses. And not only this, but it actually activates only the synapses and the neurons that can play a significant role to the final decision of the model. So the thing is that fewer operations when the world is quiet, meaning that I take an event, only the neurons and the synapses inside the neural network, inside the chip, are activated, so ultimately I consume less energy, and actually I do all my computation a lot faster. Let's move on to the way that this is working. Neuromorphic computing mainly like to work with sparse events, which means not, the usual flow of data, but a baseline of data and a spike that leads to, there's something here. Let's examine more what it is, which is going to lead us to a result. So actually it uses the spikes and it's triggered by the spikes. And even if we feed the neural network with energy image, which at the first sight has not any event or any spike on it, it actually transforms the RGB image into a spike-wise, let's say, event stream, and that's how it processes inside the chip. So that led us to understand that neuromorphic computing mainly is working better with detection tasks and anomaly. This is a use case we're working in space, especially, and where our tasks that require always-on monitoring. And with always-on monitoring, we are taking advantage of consuming less energy and having the spike, the trigger, exactly at the time that we need it. So, what kind of data we can use in the neuromorphic processor? As I already told you, they like, these chips kind of like, the data that have, events, that have, spikes. And the thing is that when we have a high rate phenomena, we can take advantage of neuromorphic because you can detect it can detect them quickly and in a very good accuracy. You can see some examples, good neuromorphic friendly data, let's say. Okay, it's the telemetry time series when for sure we have something going wrong, an event that triggers our mechanism. Of course, it's the RF and the spectrum series, where we can understand easily an interferer because it goes away from the nominal behavior of the RF antenna. And of course, event-based visual streams from event cameras, meaning that we can understand by the change of the illumination of each pixel of an image. Let's say image is not an image, it's an event stream. It's an on and off per pixel. So we can detect from there a specific thing that we want to, that we have an interest of. And that's how we have trained our model to work. And finally, what we actually use is to derive event representation from a conventional sensor, which is a typical PyCam. And that's how we convert the whole image to an event, not stream, but frame, let's say, in order to detect, in our case, cars. And I would like to say that maybe the next stage for us is to use an event-based camera in order to proceed in a more sophisticated solution about detecting from a drone something that's happening on Earth.